Today we were joined by Jack Silva, applications chemist. With that, I would like to welcome Jack.
Thank you, Sharon, and thank you for joining our webinar today. There are several types of next-gen instruments and also many older CombiFlash systems. They have different features, so the screens will look a bit different than the ones you will see here on those other systems. However, all of the functions that we will discuss today will be on these systems. You will notice some controls and features in the screenshots that I do not mention. These are advanced controls and will be discussed in a future webinar. We will generally limit the discussion to normal phase because other types of chromatography aren't run as commonly in automated flash systems. We will not discuss troubleshooting or solving problems in too much details either, as this is a beginner's webinar. This table summarizes the features on different CombiFlash next-gen systems. Older CombiFlash and competing systems will have different options, but will generally operate the same way and will have most of the features shown here. For example, solvent level sensing can keep a column from running dry and save a purification, while waste level sensing prevents a waste container from overfilling and making a big mess in the lab. RFID tags allow the system to load default methods. However, users can also manually select the column size and type they will use. Rack RFID loads the correct rack pattern automatically for the fraction collector and also the correct tube volume. This slide shows the features of older CombiFlash systems such as the RF series, the RF Plus, RF200. There will be some slight differences. If a system has an injection valve, one can set up a solid load cartridge and it will put the sample in the flow path automatically, so the sample is automatically loaded on the column. At this point, we will discuss basic operations and how to do a very simple run. There are three main steps. Set up the solvents in step 1, load the column and racks in step 2. Step 3 is where column equilibration and sample loading begins. And step 4 is where the sample gets purified. We are going to use a default method which works very well for very many runs. First, loading the solvent, you access the auto prime from the tools menu item. Priming order is important. Priming the solvents in the correct order, make sure the pumps are filled with the correct solvent to start the run. We don't want strong solvent at the start of the run because it causes poor chromatography. Some systems, such as the CombiFlash RF series and the NextGen 100, need a priming tube installed to do the priming. Strong solvent is the solvent that causes the compound to elute faster, usually ethyl acetate or methanol. For normal phase chromatography, the first solvent you would choose in the list is ethyl acetate or methanol. This is what you would choose at the top of the list as first solvent. The NextGen 100 will require a syringe to draw the liquids through the pump and effect priming. The NextGen 100 will provide priming instructions on the screen that you can follow. After the solvents are primed, the next step is to load a column. The systems with RFID tag readers will read the column size and type when the column shuttle is lifted from its lowest position. Alternatively, using File New will force the RFID tag to be read from the column. For systems without an RFID tag reader, select the column from the list. Next, optionally, enter a sample name. If you don't enter a sample name, the system will supply a unique name based on the date and time. Load the racks and press the Start button. If you need to, select the racks from a list. Systems with RFID readers will load the rack automatically. Select the loading type. Solid means that a solid load cartridge will be used. Liquid means that the sample is dissolved in a solvent and injected with a syringe. The system tells how much solvent will be needed for the run. This is your last chance to check that the correct solvents are chosen and check that there's enough solvent in the bottle so that the system doesn't stop in the middle of a run. Press OK to start the purification process. We just covered the minimum needs to start a run very quickly using a default method that the system loads when it reads a column. In the next section, we will describe how to use thin layer chromatography, TLC, and the gradient optimizer to improve peak resolution. We will discuss the gradient optimizer and how to use it. We will spend a little time on thin layer chromatography because running TLC plates correctly makes the gradient optimizer work correctly. Also, if a compound doesn't run well on the TLC plate, it will not run on a flash column. TLC is a quick test that shows whether the compound will run on silica with a given solvent system. We will talk about how to improve UV detection, how to choose a wavelength, and we will discuss how to access old runs and adding new solvents that aren't in the solvent list. Finally, if the peak didn't come off the column, what sort of simple things can we check? This is the default start screen. Everything on the CombiFlash system can be run from either this screen or the method editor screen. The first step is to load or choose a column so the gradient optimizer can use the correct parameters based on the column size. Using the method editor menu item takes you to the method editor. We will go over many of these controls later in the webinar, but right now we are interested in the gradient optimizer. This allows you to develop a method from TLC plate data. This screen is simple. It has the instructions on it. Follow the instructions as they describe the retention factor range, that is, the range of RF that will allow the gradient optimizer to work correctly. Enter the data and press OK. The target is the compound that you want to purify. The impurity is the spot closest to the desired compound on your TLC plate. It can be above or below the desired compound on the plate. It just needs to be the closest spot. We can ignore all of the other spots because we can purify them, but they are not important. You're choosing a compound that you synthesized and you wish to purify. The system will calculate a gradient with an isocratic hold. If there is enough resolution between the compound that you want to purify and the nearest impurity, the system will use the default column gradient, which will save time and solvent. Make sure you run your TLC plate properly. You see a reference on the screen from Journal of Chemical Education. The reference is at the lower right. But running a TLC plate properly means making sure the TLC chamber is saturated with vapor before running the plate. Make sure the chamber stays saturated by making sure the chamber is completely sealed. This doesn't take much time for most solvents if you prepare the TLC chamber with the solvents before spotting the plate. Ways to visualize the spots include using UV light or universal indicators such as iodine, which indicate compounds with double bonds. Oxidizers such as sulfuric acid and phospholipid acid can also be used, and a water spray allows compounds without chromophores to be non-destructively seen. If your compound shows as a black spot with 254 nanometer UV light, the default 254 nanometer UV setting on the detector will work. The black spot arises because the compound absorbs the light. If the compound absorbs the light, the zinc silicate dye on the TLC plate doesn't get any light and so cannot fluoresce the green color that you see on the rest of the plate. This makes the spot show up as a dark spot. Water spray works because most compounds are hydrophobic and protect the silica from being wet. The wet silica is gray while the dry silica is white. This is a good technique for other TLC plates such as diol and amine, which react with the oxidizing indicators such as sulfuric acid. Users often ask if their system can be used with a particular solvent. A common question concerns ethers, which are compatible with the system. There are a few solvents and mobile phase modifiers, that is, compounds added to the mobile phase, that we do not recommend. These few solvents and modifiers are listed in the colored text on the slide. DMSO and DMF do not harm the system and, in fact, are useful to dissolve samples for reverse phase, but don't use them for mobile phase. They are too viscous to be run as a mobile phase, and there are other solvents that work much better to run through the column continuously. At this point, we will describe some of the other controls and their functions. New causes the system to read the RFID tag or load a default method. Import and export are used for saving data to or loading methods from USB drives. Logout is used when multiple users are set up on the system. This allows the different users to have their own file separate from other users. Under Tools, Auto Prime was discussed earlier and allows the pumps to be filled and allows solvent changes. Manual control allows a user to control the pumps manually without running a method. Auto Zero resets the baseline. We will use the configuration screen to change the solvent list. Manual control is useful for washing columns. It is used for conditioning reverse phase columns. The pumps can be run, allowing us to look for leaks or other problems. Manual control is used for washing the system and also checking the lamp output and making sure that the lamp and flow cell are working correctly. The configuration screen allows a user to indicate which solvents are associated with each solvent line. Solvents can be added or removed from the system. Solvent and waste level sensing can be enabled. There are other things that you can see listed there that are beyond the scope of this basic training. The main screen is most useful during a run. Gradient points can be added at any time during the run by using the insert point, and the flow rate can be changed during the run as well. We saw the Start Run button earlier to start the purification and open the run requirement screen to do final checks. Stop flow stops the pump so that the run can be paused, And you use this if there's some sort of problem, and you could stop the pump and then restart them once the problem is solved. Advanced tube is useful if you want to manually move the fraction collector to collect fractions manually. You would do this if you think that you see a shoulder on the side of your peak that might be an impurity. You can manually advance the tube and maybe resolve or cut off that impurity or shoulder. To end the run early, use the terminate because it allows the system to do some cleanup procedures automatically for the next user or next sample. You might terminate the run because your peak has already eluded, and so you can stop the run early and save time and solvent. Scale method is used if you need to repeat a run on a larger column. It scales up a run that you have just finished. In the method editor, you see some of the same file commands as on the main screen. The difference here is that the file commands operate on method files and not run files. The main screen works with both method and run files. Run files contain chromatography data. Method files have information that tell the system how to run during a purification. The new button on the left forces the RFID tag column on a column to be read, or chooses a default method for a column that is showing in the column list if there is no RFID reader. You can save your method using save or save as if you change them. This is useful if you run similar compounds many times. The exit button causes some confusion to new users if there are changes made to the method. It asks you if you want to save your changes. This is asking if the changes will be applied to the current run only. If you hit yes, the default method will not be changed, only the run that you are about to perform. The method editor allows the user to enter a sample name, change the flow rate, and the equilibration volume. A user can also make notes that will be saved in the run file and displayed in the run report. These could be a sample identification or other information. Like in the main screen, the solvents can be defined and the gradient can be changed by adding or deleting gradient points or changing the run length. Also common to the main screen are peak collection detail. Collecting all causes all of the column flow to be collected into the tubes on the racks on the system. If a peak is detected, the fraction collector will start collecting those peaks in a new test tube. Collecting peaks means that the fraction collector will only collect into tubes if a peak is detected. Collecting none means everything goes to the waste container. CombiFlash systems allow a user to choose detection wavelength. This improves peak detection because choosing a wavelength with more light absorbance allows the CombiFlash detector to respond more quickly to a compound, and it improves sample recovery. On the other hand, if a compound doesn't absorb at the wavelengths entered in the peak detection, they may not be collected at all, or the peak may not be cut if you're using collect all. We discussed TLC earlier. If you see a black spot on the TLC plate when using a 254 millimeter light, you may use 254 millimeter as a detection wavelength because the compound has at least some absorbance at that wavelength. A UV vis spectrophotometer is useful for finding the maximum wavelength. Uh, it is possible also to calculate the UV absorbance and get a result that is sufficiently useful for the detection. These calculations are based on work by Woodward, Fieser, and Kuhn. You can enter the maximum absorbance into the system for detection, and we will discuss the details buttons that you see on the right within a couple of slides. Here are some examples for calculating the UV absorbance for a compound. We start with a base value and substituents increase the absorbing wavelength. These values are in the web link from the previous slide that I have copied over here as well. I will pause a second so you can take a picture with your cell phone of that link and you can look at it later. This slide shows some of the parameters that affect peak collection. We get here using the details button next to the wavelength settings that we saw about 2 slides ago. For slope-based, a larger peak width setting is more sensitive. A smaller change in slope triggers peak collection. Wider peaks usually have more shallow slope. The second wavelength is set to monitor by default. If a detector is set to monitor, it will not trigger peak collection. So if you want to collect on both wavelengths, turn off the monitor button. Threshold causes collection if the absorbance signal is greater than the set value. Making the number smaller makes peak collection more sensitive, but also more likely to be triggered by noise or a change in baseline. For best results, use both slope and threshold. The NextGen 100 and NextGen 300 without the injection valve will have fewer loading options than displayed here. Solid is for solid load cartridges. Solid with pause makes the system stop and confirm that the cartridge is before running the purification. Liquid is used for liquid injection, and again, the system will stop after equilibration and wait for the user to confirm that the sample has been injected. None means that the sample is injected before the pumps are started, and the column is also run without equilibration. A user would inject the sample at this time before pressing OK. You can see completed runs using File Open from the main screen and selecting the file name. The gradient can be seen as a blue line. This example was an isocratic run where the solvent composition did not change during the run. The 2 UV detector traces are displayed. The purple is the secondary signal. There is a depiction of the collection racks where the colored tubes match the bars under the fractions in the chromatogram. We also see a table showing the peaks and which tubes contain different peaks. The arrows at the bottom allow a user to look at other chromatograms on the next-gen system. There are 2 buttons that allow a user to save data as a PDF file or as XML text to a USB drive. I thank you for your time today. Do you have any questions?
Well, thank you, Jack, for sharing your expertise. And I would like to draw everybody's attention to the screen where we have QR codes for our social media. Please feel free to scan these, and we would greatly appreciate if you would like and follow us because this will give you any upcoming webinars and any other useful information that we post on our social media. As Jack mentioned, we are now opening for questions. So please utilize the Q&A function within Zoom, and Jack will be happy to answer. Thank you.
Okay, I have a few questions already, and I thank you for that. Our first question is, how long does it take to saturate a chamber such as a Solvent rocket? So I use chambers quite a bit larger than a rocket, and it only takes a couple of minutes to fully saturate a chamber. It usually I set up the chamber first, and then I cover it and shake it up nicely to get the chamber saturated. And then I make my TLC plate. So I scribe it and spot whatever I need to on it. And then the time it takes for me to set up the TLC plate, that's all the time that the chamber really needs to get good and ready and saturated. One comment about the Swabtech rocket, that's a cute little device. However, its design is such that you really can't saturate that chamber. You put your TLC plate in, no, you put your solvent in, and then when you put your TLC plate in, you have to take off that little dome that they have, and you lose the saturation, so you have to saturate it all over again. My preference is a small beaker. If you are working with those small plates, I recommend a small beaker, which would use the same amount of solvent and cover it with aluminum foil, and that covers the spout as well, so that the vapors cannot escape. The next question is, if you see the solvent front on the 254 nanometers, can that be an additive, or is that your material? It's hard to say. The solvent front on the 254 nanometers might be a solvent impurity that runs up at the top. It could be your spot that's spread out, although your spot should still show up as a spot. So the way to check that is to run another TLC with a weaker solvent. That is more of the weak solvent. If you're using dichloromethane and methanol, dichloromethane would be the weak solvent, and you would increase the concentration. If you are running hexane ethyl acetate, hexane is the weak solvent, and so you would run a TLC plate with more hexane, less ethyl acetate, and see if you can get that spot away from the solvent front. If you are running a spray reagent, such as any of the spray reagents that I mentioned, you might be able to see your compound hiding in a zone up near the top of the column, that spread out part. Just the other day, I had a compound that was visible with ninhydrin, and I could see a spot underneath that solvent front as well. What percentage of THF, that's tetrahydrofuran, can we use? You can use up to 100% THF, and the system will be happy with that. There's someone who said CMW on TLC. I don't know what CMW is, so if you spell that out for me, I can help with that. Oh, never mind, I see it now. Can we separate the extract that shows separation on chloroform methanol water on CombiFlash? I presume that, oh, okay, yeah. Okay, the answer is yes. That's a mixture of solvents, and what I do with that is that methanol and water I would mix together in the correct proportions as the strong solvent, and the chloroform would be the weak solvent. So I forget what the proportions are, but I've seen that mixture before and I have used it. So I would run the mixture with chloroform as the A solvent, and then whatever proportion of methanol and water you need, I would mix that together and use that as the B solvent. So that's a good question, and very interesting one. Another question is, what if my compound runs too fast with hexane ethyl acetate? There are other solvents that one can use, and one reason for using ethers is they are weaker solvents than ethyl acetate. So you can run, say, hexane dimethyl ether, for example. I'll leave this open for another little bit. If anyone has any other questions, please. Another question is, can we reuse columns? And I presume you mean silica gel, because the reverse phase columns can be reused many times. We don't usually recommend it because if you leave the column in the solvent for too long, the column body swells up and it doesn't stay packed very well. And that's true for any manufacturer's flash column, because we use the same material for the outer column body. We can buy different silicas for the column, right? We have amino as an option, but yeah, you can get different bonded phases, and they do show different selectivities. And so we have silica, we have amino, and we have alumina, and various types of C18. What about alumina? Yes, we do have alumina.
Well, Jack, that looks like you have, oh, I think another question just came in.
Yep, I just see that. Where can you purchase TLC plates to model the amine column? Places I would look for that would be Sigma Aldrich would be one place. CAMAG would be another one. I especially would recommend CAMAG since they do a lot of TLC.
Okay, we'll leave it open for a little while longer and then we will close.